getting back into Module 1 of the math from the test 2 here. These are the 6 paper tests on College Board, and this is going to be some of the best problems. We're finishing off part 3 of the Module 1 of math from this test. So getting into number 20, it looks like it's going to be an x to the third function. And when I see this x plus b part, I want to try to think of this in a certain way. Remember that if I have like an x plus 5 and I have an x plus 4, that I would think of these as, my solutions would be -5 and -4. So when I see this x plus a constant, try to think of it as that's parenthesis form. So if I had my solutions to my function, my intercepts, I could turn it into parenthesis form with a really easy step. So if I get rid of that, let's go ahead and throw this function in Desmos to see what this graph could turn out to be, right? So I pull open Desmos here, and let's type this in 2x to the third plus 42x to the second plus 208x, and it should give me my 3 solutions, right? I have -13, -8, and 0. So I write these down real quick. -13, -8, and 0, and I say x is equal to all of these. Let's go ahead and minimize our Desmos, and we're really close to being done. So if these are my solutions, we want to go parenthesis form. That's going to be the opposite, x plus 13, x plus 8, and then I could do x plus 0, but I'll just write an x on the outside. And all they want is the smallest possible value of b. b is a positive constant, so it's not going to be x. It's going to be 8 or 13, and they want the smaller of the two, so it's just going to be 8 for this problem. So not too bad. So what about number 21 here? So number 21, this should be, at this point, a systematic problem. We've seen a lot of examples of this type. I see a line, I see a quadratic here, and I see the system has exactly one distinct real solution. So real quick, if you haven't seen the other problems, let's go over all of them real fast. I'm always going to be using b squared minus 4ac, and then I'm always going to be analyzing it in terms of, is it 2 real solutions, is it 1 real, or is it 0 real? And then for each of these cases, this function becomes greater than 0, equal to 0, or less than 0 for those 3 cases. We do have a 1 real solution case, so this is going to be equal to 0. So all I do is go up above, and I do have to make it one equation, remember. So instead of y, I say it's -1.5, and then I just add it to the other side. So plus 1.5, get rid of that, and it's going to be equal to 0. So I finally have my one equation. I can try to plug in all my terms now. So my a is going to be a 1, my b is an 8, and my c, remember, is going to be everything that's not the coefficient in front of my x squared or my x. So down below, I can write 64, because I'm just writing this equation, minus 4, a is 1, and c is a plus 1.5. And then let's see what else we can write down here. So, equals 0. So what I'll do is I'll distribute this -4 times a, -4 times 1.5 to the other side. So I get 64 is equal to 4a plus 6. And I'll just erase this bit up here, and I'll kind of rewrite it in, the next step. We should get 64. I subtract 6 from both sides, or 58. 58 is equal to 4a. Divide both sides by 4, and I should get a is equal to 14.5. Or 29 over 2 works as well. But again, not too bad of a problem. It's systematic. You're always going to see a lot of examples like this. Know your b squared minus 4ac. Know the cases in which it's greater than 0, less than 0, or equal to 0, and you're fine for 21. I look at number 22. This is going to be another one that's, we will see, different versions of it. And let's start off with, it looks like it's going to be an x to the third, right? X times x times x is going to be x to the third. I see my 3 solutions. They're going to be x is equal to -6, -5, and 4. and then I see a translation. So this is the part I was mentioning. They like to include, I think, about one translation question per test. So all that's doing is -3 at the end of this function. That's all. My function, f of x, -3. And then if you glance at your answers, you'll notice a little pattern here. -6, -5, 4, -6, -5, 4. Those are my solutions. What was I getting for my solutions before this -3 translation? And it should have been 0, 0, and 0. But as soon as it's -3 at the end, it should turn into -3, -3, and -3. I already see that in B. They just take my solutions, which used to get me 0, with the -3 on at the end of my function. It's now going to turn into -3 for all three of my solutions. Is that okay? So number 22, not very bad. Number 23 here. Let's shift this over a tiny bit here. And let's see what's going on in this one. I see Q of x decreases by 45% for every increase in the value of x by 1. So this is very normal. Analyzing our x, or our amount of years, is usually the exponent in these exponential functions. Decreasing by 45%. So in my parentheses, we're looking for 55%, right? Because if I would take 100 and I would do 100 times 0.55, I would get 55. I have lost 45, which would be 45% of 100, right? So we know we're looking for the 0.55. I'm a little bit surprised by this one because they only have one answer with the 0.55. I feel like usually they'll have 2 or 3 answers with that. Let's analyze the rest of our numbers. So again, I have a normal x as my exponent, which is, again, normal. And then they're saying my y-intercept is 14. So when I plug 0 into x, 0.55 to the 0 is 1, and I'm left with 14. So C checks out. I am a little surprised they only have one answer with the 0.55, though. Looking at number 24 here, it looks like they want us to maybe come up with a line. So the graph of y equals f of x plus 14 is shown. So remember, not to get confused, this is f of x plus 14. So are there 2 really easy points for me to analyze? Always go for your intercepts. So my 2 intercepts are 0, 2 and 8, 0. Let's pull up our Desmos again, because remember, no point in having to get the equation of a line. Desmos will do it for us. Throw our table in here. Throw 0, 2 and 8, 0. And get this to do our line. And our line is going to be negative 0.25x plus 2. So let me just write that down real quick. Negative 0.25x plus 2. And then we'll hide Desmos. So you see I wrote it down there. Remember, this is f of x plus 14. So to get f of x, we have to minus 14 from this, or minus 14 from this. And it should be, and I can scroll down a tiny bit here, it should be negative 0.25x minus 12, because I take my same slope and then I just 2 minus 14 is going to be negative 12, or A for this one. This one can be really tricky. It's all about staying organized. Which one's my f of x? What change have they made? A for this one. Really good practice problem. And number 25 here, let me shift this over a little bit and move this. So our first triangle one on this worksheet, I could honestly already try to draw this out because I can see that's going to be my hypotenuse. So if I did try to draw this triangle out, it seems like TR would be here to describe my 52. And then I would just put S here. So my TS would be 48. And my SR would be 20. So not bad. Do they want me to draw a second triangle maybe? Let's see. So it's similar to this other triangle. So I'll try to scroll down so you can see this other triangle I'm going to draw right here. Okay. And let me match my angles. So R is similar to U. S is similar to V. And T is similar to W. Okay. And what is the value of tan of W? So of W, so of T. And let me get this. So tan of W is the same thing as tan of T. And that's going to be equal to, remember for tan, we want to remember, let me write it up above here, that's going to be TOA. So it's going to be opposite over adjacent. So opposite is going to be 20. Adjacent is going to be 48. And then all I have to do is reduce these two. And that's going to be 10 over 24 or 5 over 12. So again, not too bad for this one. It's just about knowing your SOHCAHTOA. I go over that a lot of times in the extra math worksheets that I uploaded. Knowing your SOHCAHTOA, drawing your triangles, your t is equal to your w, so you just work off your numbers in t, and the fractions are always going to reduce. Excellent. And we have 2 more problems left to finish off this module. Ooh, this is a very good word problem, number 26 here. Let's go ahead and jump into this one. So word problems are going to be, like geometry problems, are going to be some of the hardest problems they can include on the test because they can always make the context very confusing. So let's see what it is here. 1 gallon of paint will cover 220 square feet. So 1 gallon is equal to 220 square feet. So it's all about organizing my problems, right? A room has a total wall area of W square feet. So I always try to picture it as something that's not going to take a lot of work. So what if my total is 440 square feet, right? Always make it a multiple of whatever you're already dealing with. So I know I'm dealing with 220. I just times it by 2. So if my total is 440 square feet, that means it would take 2 gallons right now, right? Let's see what they ask. Which equation represents the total amount of paint in gallons needed to paint the walls of the room twice? So that means I would actually need 4 gallons to paint this room twice. So if I look through my answers here, W, we made 440. So if W is 440 divided by 110, that would get me 4 for the amount of gallons needed. That's already my answer. So you see, I don't even need to necessarily work around the context of like what's happening in the problem. I just throw numbers in that are logical and easy to work with. Let's try B. B would be 440 times W. W is 440. So that's going to be a massive number. We're looking, our units for P are gallons here. So we're looking for an answer that's like 2 or 4. In C, P is equal to W 440. So that's going to get 2. That's only if we paint our room once. They are painting our room twice. So that's not going to work. And then finally in letter D, that's also going to be multiplied. So it's not going to work. So A for this one, I make up numbers like I did that are multiples of the numbers you're already working with. That one was pretty easy. And number 27, let's see what's going on here. This is going to be the final problem for this module. Really good practice problems we went through. Let's see what we're finalizing with. So A is 110% greater than B. Number B is 90% less than 47. So this is one where I actually skip the first part because I can actually solve for my second part. So B is equal to 90% less than 47. So think of what 90% of 47 is, or think of what 100%, or rather 10% of 47 is. That's just going to be 4.7, right? So if I have 10 of these and it's 90% less, I get rid of 9 of them. B is just going to be 4.7, right? And then now is where the percentages can get a little bit odd. They say A is 110% greater than the number B. So 100% greater than 4.7 is what? And that's just going to be 4.7 times 2, right? So I never want to make any mathematical errors. So my 4.7 times 2 is going to be 9.4. That is 100% more. So to get that little extra 10%, I just do 0.1 times 4.7. Or since I know it's twice as much and an extra 10%, I could do 2.1 times 4.7 and I get 9.87. So I could do the 100% more with 10%, or I could just do 2.1 times and I get that. So a nice little finale, not too crazy of a final problem, but it's really important to master our percentages like that. That's going to be the end of Module 1. We're going to be jumping to Module 2 after this.